looking at the impact of climate change and marine heat waves on fisheries in West Australia. I'd like to acknowledge Arani Chandrapavan, who's contributed to this presentation, as well as other colleagues from Fisheries Research, and Ming Feng from CSIRO, an oceanographer who's contributed to this. So I'll be looking at what are marine heat waves and defining them. In particular, we'll look at the 2011 extreme marine heat wave that affected West Australia. We'll look at its cause and its effect on the marine ecosystem. Then we'll look at some case studies, looking at rose abalone, scallops, sharkbait crabs, and the western rock lobster. And before we get started, thought I'd give an overview of some West Australian fisheries. There are basically 48 fisheries, many of them quite small, looking at over 200 species, worth over $500 million. And they're in the marine and freshwater area, mainly in the marine area. We've got a vibrant commercial sector, a recreational sector with many recreational fishers, a developing aquaculture sector, and with some indigenous fisheries. Our approach to management is an ecosystem-based fisheries management, which means that we not only assess the fish stocks, but we also assess the fishing effect on the ecosystem more broadly. Any interaction with protected species is looked at very closely. We monitor catches, we undertake surveys on juveniles and spawning stock, and we try to set sustainable catch levels in each of our fisheries. There are 11 fisheries which are Marine Stewardship Council certified, which represents more than 80% of the value of West Australian commercial fisheries. And these MSC certification is a third-party certification of fisheries to ensure that they are sustainably managed. Okay. Let's look at the water temperature increases, and on the map you can see that West Australia is one of the hotspots of water temperature increases, which means that the long-term water temperature increase here is above the national average, and you can see the other marine heat wave, the other areas of water temperature increases, including Southeast Australia. On the right, there's a showing the water temperature anomalies over 100 years, and you can see it goes from half a degree below average to half a degree to 1 degree above average over the last 100 years. Now, what are marine heat waves? The actual term itself was coined in West Australia by a fisheries scientist, Dr. Alan Pearce, and it's basically been defined as 5 or more consecutive days with the water temperatures above the 90th percentile for that time of year. So if we look at the graph, we can see time of year along here, and the black line represents the mean temperature, and then we've got the 90th percentile just above it. So with the water temperature above this 90th percentile for more than 5 days, it's defined as a heat wave. And these heat waves are classified similarly to the way we classify cyclones, from moderate to extreme. And this dashed line represents an illustration of that heat wave, where this is the intensity and this is the duration of that heat wave. So let's look at some marine heat waves that have occurred over the last 15, 20 years around the world. We've got off North America the largest and the longest heat wave, 711 days, and it was labelled the blob. But in West Australia, it's not the biggest heat wave, but it's the most extreme heat wave that's been experienced anywhere around the world. And that happened in 2011. Now let's see the causes of it. And one of the contributing factors, and I'm sure you've heard of the El Nino Southern Oscillation Index, where we've got in La Nina situation, we've got strong trade winds pushing warm waters towards the east coast of Australia, towards the north. When this happens, you get an increased chance of rainfall happening over the eastern part of Australia, and that's contributed to some recent floods that have occurred of the east coast of Australia. In an El Nino situation, these trade winds are weaker, and that warmer water is focused in the America side of the Pacific. In West Australia, off Australia, we've got cooler than normal temperatures and reduced chance of rainfall and droughts happening quite frequently. But there's no impact on the rainfall in West Australia. The impact in West Australia is with this warm water in a La Nina situation flowing down the coast and contributing to a strong Lewin current. And the opposite happens when this cool water here, there's a weak Lewin current flowing down south. So in terms of the causes of the 2011 extreme marine heatwave, we've got this strong La Nina event with increased warm water flowing down through Indonesia down the west coast. And this is an illustration of the Lewin current in red coming down the west coast, forms eddies off West Australia. So this strong Lewin current in this situation strengthened over summer when it's usually weaker than a normal, but also at the same time we had weak southerly winds, and these winds contribute to a Capes current which flows north along the coast and typically would cool the water temperature. Now this was weak in this year, so that didn't happen. A third contributing factor is the high air temperatures, where there's a greater warming of the ocean from the atmosphere, and it's called the air-sea heat flux. So let's look at the 2011 marine heatwave. This is the daily sea surface temperatures at the Abalone Islands. And in black, we've got the average temperature over the year at the Abalone Islands. In red, we have the 90th percentile, and anything above the red represents in the top 10% of water temperatures. In purple, we have the 2011 temperature, and you can see that it started to go above the 90th percentile at the start of the year. By late February, early March, it peaked to 5-6 degrees above the average temperature. And this was the peak of the marine heatwave in 2011. And then it came down after that. So this is in 2011, the marine heatwave, and you can see it occurred over a wide area from virtually Ningaloo through to the south coast of West Australia and over a large area of Western Australia. Now we've got the subsequent 11 years, summers, and you can see the water temperature persisted to be above average in 12 and 13. So we had very warm summers for 2 years, returned to average summers in 14, 15, and then in 16, things started to cool again. And that peaked in 2019, where water temperatures were well below average. And this period we refer to as the marine cold spell, where water temperatures were below the 90th percentile and below average. The last 3 summers, we've had warmer than average temperatures, and they constitute a moderate heat wave over the last 3 summers. This time series show water temperature anomalies for the last 30 years, and you can see typically La Nina conditions brings a warm marine heat wave, 99, 2000, and 10, 11, and the El Nino conditions with weaker Lewin current bring below average temperatures. Now, what effect did that have on the marine ecosystem? Well, it had a major impact. Phytoplankton blooms occurred in many places. There was coral bleaching at Ningaloo and the Abalone Islands, major loss of seagrass in Shark Bay. There were kelp forests lost in the Midwest region. There were fish kills in different areas of the state, and many fisheries were affected. Some were closed for years. The only good news that came out of it was a range extension of some tropical species, where tropical species were seen further south than they would normally be seen. And we need to think of these extreme marine heat waves the way we think of droughts and cyclones effect on land. So let's look at Shark Bay and the impact on the seagrass there. This is the seagrass distribution in 2002 before the heatwave. This was the seagrass distribution after the heatwave. And in red, in the third panel, we see the areas where the seagrass was lost. So a major loss of seagrass meadows in the Shark Bay. The other thing that's been happening in Shark Bay, which is different from what's happening on the coast, is that you're getting the warmer temperatures in the summer period compared to the 1980s, but in winter, it's actually getting cooler. So the winters are getting cooler and the bottom temperature is happening 2 months earlier than what had happened 40 years ago. At Abalone in the Midwest region, in Kalbarri in particular. This area was near the centre of the heatwave, and this stock of rose abalone is near the northern end of its range in Kalbarri. So it's nice. We had a virtually more than 99% mortality straight after the heatwave, and these are photos from before and after the heatwave. We've translocated some abalone and released some hatchery-reared abalone in this area, and they've survived, but they've only been at an experimental level. So we've had no recovery of this abalone stock in the 12 years since the heat wave. Let's look at the same species certain area. And this is the Waterman Research Labs at the back here. So it's an area close to the Trigg Waterman area. And this is an important commercial and recreational fishery. And the recreational fishery is only lasts for 4 days each year and for about an hour each day. And you can see the popularity of this fishery when it is open. We've been undertaking extensive surveys of these stocks for the last 20 years. And let's look at the results of those surveys. So these are dive surveys looking at the abundance of different age classes. And on the horizontal axis, we've got the juvenile abundance of 1-year-old abalone. And on the vertical axis, we've got the legal size abundance 4 years later. So prior to the heat wave, this was the relationship that we had. And this relationship was used to set the management settings for this fishery. So this was the relationship prior to the heat wave. When the heat wave happened in 2011, the abundance of legal size animals was half what it was prior to the heat wave. And there was a 50% reduction in the catch and the significant changes to the management settings over this period of the marine heat wave. Then we had the cold spell occurring, and that started in 16 and continued through to 19. And you could see that the abundance of legal size were above where it was in the pre-heat wave period. And then more recently, so these are the predicted catches of what the abalone is going to be doing over the next couple of years in 22 and 23. And we're expecting a moderate reduction of the legal size abundance as a result of the moderate heat wave that is currently occurring. So basically, we've got the water temperature affecting the density and growth of abalone over this period. Moving on to Shark Bay crab fishery, and this shows the abundance of water temperature in the summer and the abundance of legal size abalone. It's on a logarithmic scale on the vertical axis. And again, you can see when the heat wave happened in 2011, we had very low abundance of legal size abalone, and the fishery was shut for a period of 18 months. And here we've got the catch. This is the developing part of the fishery. This was the historic catches prior to the heat wave, during the heat wave, and you can see a recovery afterwards. And again, going back to this graph, we see the recovery of this stock when the marine cold spell happened in 16, 17, 18 and 19. More recently, once again, the moderate heat wave we've experienced, we're predicting a decline in the abundance of legal size when we do the survey later this year, but nowhere near as bad as what it was in 2011. The third fishery I want to look at is the Western lobster fishery, and what we've got here is the Phylosoma larvae. Once spawning starts in the Western lobster fishery, the larvae move out in the open ocean for 9 to 11 months, and then a small percentage of them come back to the coast and take the shape of a lobster. We call this stage the purulus stage. And it takes about 3 years for this purulus stage to grow to a legal size. And these purulus settle along the coast. One of the major breakthroughs in lobster research happened in the late 60s in Western Australia with the development of these purulus collectors. And these are collectors which are put out in the ocean on the coastal region, and they measure the abundance of the purulus which settle along the coast. We currently monitor the abundance at 8 locations from Port Gregory up north through to Cape Mental down south, and we sample these monthly using these collectors. This shows the abundance of the purulus since the late 60s, and you can see there's wide fluctuation of this purulus settlement along the coast, and it's in sync where it's good, it's everywhere it's good. And we knew that the good purulus settlement was associated with a strong Lewin current, so we had a good understanding of these fluctuations. But then in about 2007 and 8, we had a major downturn in purulus settlement, went down to record low levels, and it couldn't be explained by the environmental factors that we knew explained this variation. So we were back to square one in terms of our understanding of the cause of this poor purulus settlement. The importance of the purulus settlement is reflected in this relationship between the Alkimos settlement and the catch in the Lancelin area 3-4 years later, where typically you'd get 3,000 tonnes in this area in a good settlement year and about just over 1,000 tonnes in a poor settlement year. So a significant decline in purulus settlement had a major impact on the catch, but also would have a major impact on the breeding stock. So a major research program was put in place in collaboration with CSIRO, where we developed a larval movement model, which is a 3-dimensional complex model to understand what the larvae was doing out in the open ocean. And we looked at 18 years of data prior to this decline and afterwards, and after the decline. And this decline happened before the heat wave, so there wasn't a marine heat wave impact. This shows the modelling of the larval movement. It's in 2-dimension, but these larvae are actually moving up and down the water column on a daily basis. And you can see the larvae move well offshore the West Australian coast. The spawning occurs in spring and summer of 1 year. And as I said, they spend about 9 to 11 months in this open ocean. And about the winter time, when the winter storms kick in, some of these larvae, again, a very small percentage of these larvae come back to the coast. The modelling actually shows all the larvae that successfully come back. And you can see the Lewin current in the background forming eddies, which help retain some of these larvae. Now, at the same time that we did this larval movement model, we also did a statistical assessment of the spawning stock, the environmental conditions, and the purulus settlement, and we identified that warmer temperatures was affecting the timing of spawning. Spawning was occurring earlier, and there was also reduced winter storms, and these combination of factors contributed to this lower settlement over this period. But irrespective of the cause of the low settlement, the low purulus meant that there was going to be a low abundance of lobsters, so management intervention was brought in place where there was reduced catches for a significant period to protect the spawning stock. And this was successful, as the spawning stock now is at a record high levels because the fishery continues to be fished quite conservatively. Another effect on the marine heatwave happened on the lobster fishery happened a year later. And this shows the peerless time series in blue for the Kalbarri region. And remember, Kalbarri was near the center of the heatwave. And in red, we've got the juvenile abundance. And prior to the heatwave, there's quite a good relationship with the peerless growing to juveniles 2 years later. But after the heatwave in 2011, you see the peerless stay within historic levels, but the juvenile abundance went to record low levels. So clearly there was a lack of survival or growth of these peerless between the peerless stage and the juveniles, which could be due to food changes in this area or changes in habitat in this area. If we go further south, an area that wasn't in the center of the heatwave, but still mildly affected by the heatwave, we see that the relationship between the peerless and the juveniles before the heatwave and after the heatwave was pretty similar. We're starting to see a slow recovery of the juvenile abundance in the Kalbarri region. So hopefully in the next few years, there'll be a full recovery of this area. Looking at another case study, here we're looking at the Abalone Island scallop fishery. And these scallops occur on the sandy bottom in the lee of the Abalone Islands. And scallops worldwide are known to be highly variable. And on top here, we've got the catch over the years at the Abalone, and you can see it varies quite a lot from year to year. And even prior to the heat wave, we knew that water temperatures had a negative impact on the recruitment of abalone in the Abalone region, and also had a negative impact on the scallop fishery in Shark Bay. And again, we've been surveying this stock for over 20 years, and this graph shows the spawning stock on one axis and the recruitment in the following year. The life cycle of scallops is they survive only 2-3 years. And we, as I said, we knew that warm temperatures had a negative impact on scallops. So this is the warm temperature, 24-degree line, and 23-degree line was producing good recruitment. So in 2011, we had a very good spawning stock, but when the heat wave happened, as expected, there was a decline in the survival of juveniles in the following year. That resulted in the spawning stock going down to record low levels, and with the continued warm temperatures in 12 and 13, the abundance of scallops was at record low levels for 4 or 5 years, and this fishery was actually shut for 5 years during this period, and hoping for the stock to recover. When the marine cold spell started in 2016, we started to see the first signs of recovery, and that recovery continued until 2019 during this marine cold spell period. And once again, with the warmer temperatures over the last couple of years, the abundance has declined, and the fishery is actually shut for this year. But we think that will only be for 1 year because we're seeing signs of recovery already. And like I said, it's not all gloom and doom. Some tropical species at the southern end of their distribution are being positively impacted by water temperature. And again, this is the same scallop stocks on the south coast. The water temperature on the horizontal axis, it's typically 4 or more degrees cooler down south. So the warm temperatures actually brought the water temperature to optimum conditions, and there were good catches of scallops during this marine heatwave period. And I could show you the same sort of graphs for blue simmer crabs down south. They did well in the during the heatwave period, but the increase here did not offset the major loss of scallops in Shark Bay and at the Abalone, where they are major fisheries. This shows the an IPCC assessment report data on the global surface temperature change and the increase relative to the 1850 to 1900. So this is a worldwide temperature increase from 1950 here through to where we are here. And these are the projected increases that can occur from a low emission scenario to a high emission scenario. But the take-home message here is that even with a low emission scenario, over the next 15 to 20 years, we're going to have an increase of at least 0.5 degree on a worldwide basis. So effectively, this means that marine heat waves are going to continue to increase over the next 15, 20 years. One of the proposals that's been put together in West Australia is trying to advance our observations and predictions of marine heat waves, where we want to predict these anomalous temperature events at a seasonal scale that's relevant to the management of fisheries. As part of this project, we're looking at bringing in some smart moorings along the coast that will provide real-time surface and bottom temperature information. Remember, satellite information is good for surface temperatures, but obviously not good for bottom temperatures. Another associated project with this proposal is looking at marine heat wave effect on the lobster fishery, particularly in the Kalbarri region. Now, this was a challenge put forward by RNE and myself to the marine community in West Australia, and the proposal is being led by UWA scientists, and they're leading a multidisciplinary team from West Australia and national research institutes to try and increase our understanding of the heat wave and their effects on the marine ecosystem. So effectively, what we want to go forward is a climate-informed fisheries research and management approach, where we've got a changing climate, we've got warming oceans, and we've got ocean extremes affecting the marine ecosystem and fisheries. There's winners and losers, but at the moment we're seeing more losers than winners. And these marine heat waves are going to increase in intensity, frequency, and duration. So we need the climate and environmental information, which is critical to our understanding the abundance distribution of the biological changes. So we need early detection of these changing ocean conditions. We need early warning of the stock changes through surveys, particularly the juvenile surveys, that gives us an ability to be proactive in our management and intervention to protect the spawning stock, to help in the recovery of these stocks if they get affected. And around this slide are some papers that reflect some of the information that we've presented today, and some websites on marine heat waves and climate change effect on the marine environment together. So that's the end of my presentation, and happy to have any questions.
Thanks, Dr. Nick. I'd like to also open it up to Jenny and Joe if you'd like to ask any questions. But the cold spell after the 2011 marine heat wave, was that by chance that it occurred, or is it like a feedback cycle, something that we could expect that after these La Nina heat waves we might see cold spells? Or was it just luck? And did that really assist in the more rapid recovery of some of our species?
I think the cold spell was associated with an extended El Nino event. It happened over that period. There was a couple of El Nino events, and with El Nino events, you get a weak Lewin current and generally cooler temperatures. So again, there was a combination of events that occurred. And yes, that marine cold spell certainly helped in the recovery of the Scallop fishery and the Shark Bay crab fishery. I think without it, we would have stayed in that closed area of fishery for an extended period. So it was a major impact on the rose abalone as well in the metropolitan area, you saw that when that cold spell happened in 16, we started to see a big jump in the survival of the juveniles to legal size. So yeah, it had a major impact on the recovery.
With the rock lobster, how there was the difference between the purulus that stayed high but the juveniles dropping. Could this be possibly due to the stratification that occurred that may have blocked the food source of the purulus?
Well, there was only stratification at the time of the heat wave. As I said, with the calm conditions, we had some deoxygenation of the waters happening for a period of time, which caused some fish kills, which certainly might have killed some prey. But after the heat wave, obviously there was a change to the environmental conditions in that Kalbarri region or that Midwest region, which has affected a long-term impact on either the food or the habitat in that region, that has stopped the recovery of that juvenile abundance. So that's one of the areas that we do want to study a bit more in that proposal that's been put forward. So there was a short-term impact at the time of the heat wave as a result of the stratification of the water, and then there was some fish kills associated during that period. But then there was, and there's a long-term impact is obviously present as well that we haven't recovered from.
The relationship between long-term climate change and these marine heat waves, is it that the increasing sea surface temperatures or global atmospheric temperatures are increasing the frequency of heat waves, or do they just exacerbate the impacts by the high ocean temperatures that would prolong the heat wave? Do we have an understanding on the impact between these heat waves and climate change?
Yeah, well, the long-term water temperature increases, as that increases 0.5 degree, then that, in combination with a La Nina event that might be occurring, that contributes to the above average water temperature. So you've got a combination of a long-term increase plus a short-term spike, and the combination of the two contributes to that marine heatwave event. And with the water temperature increases, we're basically going to be seeing more extreme La Nina events and El Nino events. So the more extreme event will contribute to a greater impact on the Lewin current, and then that results in a greater impact on the water temperature. So yeah, the two things are interrelated. With the long-term increase is contributing to the increase in frequency, intensity, and duration of marine heat waves.
So we're seeing La Nina, a couple of La Nina events over the last year. Is it just the scallop fishery that we're expecting to see a closure on, or could it possibly have other impacts? Now that you're talking about early detection and early warning, are we predicting other fisheries being impacted by the current La Nina systems?
I think the scallop fishery is the one we've identified that's had a major impact, but certainly in the other fisheries like the Shark Bay crab fishery, and that's a fishery that RNE supervises, we're seeing a downturn in the abundance of that. But what we might see is a mild reduction in the quota of that fishery. We don't expect, it's not like the 2011, which resulted in the closure of that Shark Bay crab fishery for 18 months. At this stage, we're expecting a reduction in the quota of that fishery, and probably the same in the Rose Abalone fishery in the metropolitan area. We might see a reduction in the catch and a reduction in the quota of the commercial fishery for that fishery. So we're seeing a milder impact as a result of the current moderate heat wave compared to the extreme heat wave in 2011. But we are seeing an impact in a lot of our fisheries. But as I said, the most extreme ones at this stage seems to be the Scallop fishery.